Mayor Napipito. I am George L. Valencia, the reporter for this afternoon. So I'm going to report topic 11.8, the median test. So I have a slide here. Don't disturb me. I'm reading median test. So let's first define what's median test. In statistics, Moore's median test is a special case of person's chi-squared test. It is a non-parametric test that tests the null hypothesis that the medians of the populations from which two or more samples are drawn are identical. The data in each sample are assigned to two groups, one consisting of data whose values are higher than the median value in the two groups combined, and the other consisting of data whose values are at the median or below. A person's chi-squared test is then used to determine whether the observed frequencies in each sample differ from expected frequencies derived from a distribution combining the two groups. So the median test is a procedure testing whether two independent groups differ in central tendencies. More precisely, the median test will give information as to have been drawn from population with the same median. Null hypothesis, the two groups are from populations with the same median. For the alternative hypothesis, the median of one population is different from that the other or the two-tailed test, or that the median of one population is higher than that of the other with the one-tailed test. The test may be used whenever the scores for the two groups are measured on at least an ordinal scale. How to perform median test? So to perform the median test, let's first determine the median score for the combined group. An example, the median for all sets, we then dichotomize both sets of scores at the median and cast this data in a 2 by 2 table like the one below. So we have the median test. This is the form of data as shown in the figure. So we have group 1 and group 2. So on the left side, we have the number scores above combined median and the number of scores below combined median. So we have letters as representatives. So now if group 1 and group 2 are samples from populations whose median are the same, we would expect about half of each group's scores to be above the combined median and about half to be below. That is, we would expect frequencies A and C to be about equal and B and D as well. It can be shown that if A is the number of the M cases in group 1 that fall above the combined median, and if B is the number of the N cases in group 2 that fall above the combined median, then the sampling distribution of A and B under the null hypothesis is the hypergeometric distribution. So to get the median of the test, we have this equation. So P, A, comma B is equal to A times B all over A plus B. Therefore, if the total number of cases in both groups, we have the sum of M and N, is small, one may use the Fisher exact test to test the null hypothesis. If the total number of cases is sufficiently large, the chi-squared test with DF is equal to 1 may be used to test the null hypothesis. When analyzing data split at the median, the researchers should be guided in these considerations in choosing between the Fisher exact test and the chi-squared test for a 2 by 2 tables. So when N is equal to M plus N is larger than 20, you have to use the X squared corrected for continuity. So the formula is X squared equals N times AD minus BC N over 2 squared all over A plus B times C plus D plus A plus C times D plus D. So in the book of Daniel Wayne W. Applied Non-Parametric Statistics, second edition, the test statistic used is a normal approximation. So this is the example that I have shown earlier. So the T is equal to A over M minus B over N all over the square root of P probability times 1 minus P times 1 over M plus 1 over N, where P is equal to A plus B all over N. So how it is approximated? It starts from the Fisher exact test statistic, which is the PDF of a hypergeometric distribution. Then we use binomial approximation to it, and which goes to normal approximation to the binomial random variables. So where n is equal to m plus n equals 20 or less, you have to use the Fisher exact test. The decision rule. For chi-square test statistic, we reject null hypothesis, which is x squared greater or equal to x 2 over v with degrees of freedom v is equal to n. For normal approximation, we reject null hypothesis if z is less than or equal to negative z over za over 2 or z is greater than or equal to za over 2. So an example, in a cross-cultural test of some behavior theory hypothesis adopted from psychoanalytic theory, Whiting and Child studied the relation between child-rearing practices and customs related to illness in various non-literate cultures. One hypothesis of their study derived from the notion of negative fixation. Was there oral explanations of illness? Illness results from eating poison, from drinking certain liquids, and from verbal spells and incantations performed by others. So judgment of the typical oral socialization anxiety in any society were based on the rapidity of oral socialization, the severity of oral socialization, the frequency of punishment typical in oral socialization, and the severity of emotional conflict evidenced by the children during the period of oral socialization. Excerpts from ethnological reports of non-literate cultures were used in the collection of the data. By using only excerpts concerning customs relating to illness, judges classified the societies into two groups, those with oral explanations of illness present and those with oral explanations that are absent. Other judges, using the excerpts concerning child-rearing practices, rated each society on the degree of oral socialization anxiety typical in its children. For the 39 societies for which judgments of the presence or absence of oral explanations were possible, these ratings changed from 6 to 17. So for the solution, null hypothesis, there is no difference between the median oral socialization anxiety in societies which give oral explanations of illness and the median oral socialization anxiety in societies which do not give oral explanations of illness. For the alternative hypothesis, the median oral socialization anxiety in societies with oral explanations present is higher than the median in societies with oral explanations absent. Level of significance, let alpha be equal to 0.01 and n is the number of societies for which technological information on both variables was available is equal to 39. M is the number of societies with oral explanations absent equals 16, and n is the number of societies with oral explanations present is equal to 23. So for the test statistic, x squared is equal to n ad minus bc over I times n over 2 all over a product of a plus b, c plus d, a plus c, and b plus d. For the rejection region, since Each one predicts the direction of the difference. The region of rejection is one-tailed. And reject null hypothesis if the answer is greater than or equal to 6.635 with alpha 0.01. Otherwise, do not reject it. So for the computation, we have oral socialization anxiety and oral explanations of illness. So there are two groups. So we have societies with oral explanation absent and societies with oral explanations present. For the left side, we have or the y-axis. So we have societies above medians on oral socialization anxiety. We have 3 for absent and 17 for present. For societies below medians on oral socialization anxiety, so 13 for absent and for present is 6. So the total for the societies with oral explanation absent is 16 and for those that are present is 23. So x squared, so to compute, so x squared, we have the answer is 9.39. So you just get the values from the table above. So the decision, since the computed x squared is greater than 6.635, then we have to reject the null hypothesis since the alpha is 0.01. Conclusion. Therefore, we conclude that the median oral socialization anxiety is higher in societies with oral explanations of illness present than is the median in societies with oral explanations absent. So another example, we have Russell reported the stroke index values shown on the table below for patients admitted to the myocardial infarction research unit of a university hospital. You wish to know whether these data provide sufficient evidence to indicate that the medians of the two populations represented by the sample data are different. So let alpha be 0.05. So this is the table shown below. So stroke index values, we have millimeters for patients admitted to the myocardial infarction research unit of a university hospital. So the diagnoses are anterior transmural infarction and anterior necrosis, which is represented by X, and inferior transmural infarction and inferior necrosis as represented by Y. So for the solution hypothesis, we have the null hypothesis. Mx is equal to Mi, meaning the myocardial X, and the other one is Y. Then the alternative hypothesis, Mx is not equal to Mi. Let the level of significance, the alpha is equal to 0.05. So for the test statistic, so test is equal to A over N1 minus B over N2 all over square root of P times 1 minus P times 1 over N1 plus 1 over N2, where P is equal to the sum of A and B all over N. For the rejection